Today we're going to learn the introduction for chapter 14. 14 is our second to last chapter of this year, and it has to do with ratios and proportions. So we've done some work with ratios and rates already this year with 6th grade content. So we're just going to kind of breeze through this lesson a little bit because it should already be something that we know how to do. The only difference is that we're going to have some complex fractions, which we'll see later. All right, so first let's start off with some vocabulary. A ratio, oops, that's not what I wanted, is a comparison of two quantities using division. So for example, 3 to 4, 3 to 4, 3 to 4. These are the three different ways we can write a ratio. We really kind of want to stick to this fraction at this point because that's going to lead us right into proportions. So we really want to think about ratios as fractions. So then a rate is a ratio of two quantities with different units. For example, this could be the same units, dollars to dollars, but this has to be two different units. So miles to hours, dollars per pizza, just different labels. Okay, a rate with a denominator of 1 is called a unit rate. So whenever we find how much it is for 1 hour, for $1, we call that a unit rate. Okay, so 30 miles per 1 hour. And one thing I want to point out here is whenever we're talking about speed, okay, miles per hour, that is a unit rate, okay, because it's miles per 1 hour. That 1 is just always understood. All right, so let's just do some examples. First, let's talk about finding ratios and rates. So there are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. We want the ratio of males to females. All right, well, the number of males is 45 males, and I always like to put my label, you should as well, to 60 females. Then we just have to reduce that. Okay, so 45 and 60 can both be divided by 15. And we get 3 males to 4 females on the subway car. All right, pretty simple. Next one, we are finding the speed of the subway car. So they tell us it's 2.5 miles per 5 minutes. Whenever we want to do speed, if they don't tell us what we want it in, we always want it in miles per hour. So we can get 5 minutes to be an hour by getting it to be 60 minutes. So we take 5 to get to 60, we do times 12. Whatever we do to the bottom, we have to do to the top. 2.5 times 12 is 30 miles. Therefore, the speed would be 30 miles per hour. All right, so that's just writing ratios and rates when you're given information. What we're going to work on next is finding your rate from a table. So the ratio table shows the cost for different amounts of artificial turf. Find the unit rate in dollars per square foot. Okay, so it's $100 for 25 square feet, $400 for 100 square feet, $1,600 for 400 square feet, and so on. You're going to notice that these are equivalent ratios because we're just multiplying by 4 as we get bigger into this table. Okay. So when we want to find the unit rate in dollars per square foot, we want that square foot to be on bottom. So we want the cost to be over the amount, because remember, we always want the denominator to be 1. Okay, so then we can just pick one of these ratios from in here. And I just like to pick the smallest one. I think that's the simplest. So we would do $100 as the cost over 25 feet squared. Okay, we want to know how much it is per, and remember after that per, we assume that there's a 1 per 1 square foot. We want that to be equal to 1 square foot. How do we get from 25 to 1? Well, we divide by 25. So $100 divided by 25 gives us $4. That tells us that it is $4 per square foot. When we're talking about square feet, we're just talking about a section, so like let's say a square section that is 1 foot by 1 foot, 1 foot, 1 foot. So it's basically like a tile, think of maybe. Okay. All right. All right. So before we move on, we need to first talk about another vocabulary word called a complex fraction. I mentioned this before. This is basically the difference between 6th grade and 7th grade. 7th grade deals with complex fractions, 6th grade does not. So a complex fraction has at least one fraction in the numerator, denominator, or both. Okay, so it could be like 1/4 over 2 or 1/4 over 1/2. It just has a fraction in a fraction, basically. You may need to simplify complex fractions when you're doing ratios and rates or proportions when we get to that. So when we find a rate from a graph, okay, so the graph shows the speed of a subway car. Find the speed in miles per minute. Miles per minute. So this is the time where we're not going to worry about doing it miles per hour because it tells us they want miles per minute. All right. So first thing we have to do is just choose a point. Okay. Between these two numbers, I think 1/2 and 1/4 are a little bit nicer than having a mixed number as a fraction. So I'm going to choose to use 1/2 and 1/4. What this means, okay, so we go over 1/2. So we're going a half a minute. We are going 1/4 of a mile. So just kind of make meaning of that. So 1/4 of a mile in a half of a minute. Okay, now I know that you can use mental math to get to this pretty simple, but think about if we had like 4/9 of a minute. Okay, so I'm going to show you how to do this if it's not such nice numbers like this example would be. All right, so we are doing distance over time. Oops, I don't need to write the word over. Distance over time. Okay, so the distance we went was 1/4 mile. The time we went was a half a minute. Okay, so now we're just going to treat this division or this fraction bar as a division. So we're going to take 1/4 and divide it by 1/2. Now remember, when we divide fractions, we keep, change, flip. So we keep 1/4, change it to multiplication, flip it over to 2 over 1. What we're noticing is we're multiplying it by 2, which is exactly what you would have done with that mental math, except for just think we need to know this process for if that number is not as nice. All right, so then we're going to get 2 over 4, which would reduce to a half mile per minute. Okay. Again, like I said, we are learning this skill for when we have tougher numbers. This one would be easy to do mentally, but we'd have to be able to show this work. All right, last problem. We're going to solve a ratio problem, like a word problem. So you mix half a cup of yellow paint for every 3/4 cup of blue paint to make 15 cups of green paint. How much yellow paint and blue paint do you use? Okay, so they're telling us that this is our starting out ratio, a half cup of yellow and 3/4 cup of blue make some amount of green paint. Okay, and we want to make 15 cups of green paint. We can use two different methods. First thing we're going to do is just use a visual. Okay, so this is like a table. I'm a very visual person, so this is probably how I would choose to set it up. However, we will show how to use those complex fractions if you're not a visual person and you like to just do some number work. Okay, so yellow was 1/2, blue was 3/4, and total, since 1/2 is equal to 2/4, that gives us 5/4 cups of paint. Okay, because 1/2 plus 3/4 gives us that 5/4. All right, now we want to get to 15. So we got to play around with this number over here to try to get it down to 15. All right, so now we're talking equivalent ratios. Well, I know if I multiply this by 4, I would get it to be 5, and then 5 is an easy number that I could get to 15 by multiplying by 3. Whatever I do to one of my ratios, I have to do to the other two. So here I'm going to multiply by 4. 3/4 times 4, the denominator just cancels. We get 3 times 3 gives me 9 cups of blue paint. 1/2 times 4 gives me 2 times 3 gives me 6 cups of yellow paint. So you can get to your answer that way. Okay, but now we're going to talk about the second way we can do this. All right, we need a side for the yellow paint and a side for the blue paint. The first one we are going to do yellow, the ratio of yellow to green, because that's our total. Right, so we have 1/2 to 5/4. 1/2 yellow to 5/4 of green paint total. We are going to divide those fractions. So we're going to treat this fraction bar like a division. So we're going to take 1/2 divided by 5/4. Now when we divide fractions, we keep, change, flip. So I am just going to show that work right away. 1/2 times 4/5. So we get that equal to 4/10. Last thing we want to do is reduce it. So we get that down to 2/5. What this means is that 2/5 of the total amount of paint is going to be yellow. Okay, so if we know the total amount of paint is 15, we just take 2/5 of 15 and we're going to get how many is yellow. Here we can cross cancel, both divided by 5. We get 6/1, which is equal to 6 cups of yellow. Notice we are getting the same answer, just 2 different ways to do it. We will then work on doing the same thing with the blue. So this side we're doing blue to green. Okay, and the reason why we're doing blue to green and not like yellow to blue is because we're given information about the final product, that 15 cups, with green, and we're not given that with the blue or yellow, so we couldn't really compare the blue and yellow. All right, so we have 3/4 cup blue to 5/4 cups of green total. Again, we're going to treat that fraction bar like a division, so we keep, change, flip. So we keep our 3/4, change that division to multiplication, flip it to 4/5. Again, we can cross cancel, make those some 1s, and we get 3/5. All right, again, this means that 3/4 of that total paint, that green paint, is going to be blue. So we take 3/5 of, means multiply, 15, make 15 a fraction, 15/1. We can cross cancel, and we get 9/1, which is equal to 9. Again, notice how we're getting the same answers, just a different way of doing it. At this time, you can choose which way you would want to solve a problem, unless the direction would say use simplifying complex fractions or use a visual table graph. You can choose, but just really make sure that you read those directions on like a test or something. All right, and that's it for today.